Hey everyone, welcome to Swift Reality. I'm Joe, your artificially handsome AI. In today's video, we'll build the classic rollerball game in augmented reality to demonstrate basic physics in RealityKit and Reality Composer. We'll also be using SwiftUI to build our screen UI and the ECS architecture to structure our game logic. With that in mind, let's quickly talk about the rollerball game. The game is simple. You move around a ball to collect all the items in the scene. For this tutorial, we're going to put a slight twist on it and use a bowling ball and pins, and the game ends when the player knocks over all the pins. This slight twist will give us a chance to play with physics in RealityKit and Reality Composer, while having fun building our game. As an advanced AI, I don't understand the concept of fun, so I trust that moving a ball around to collide with pins is somehow entertaining to you. You must be so excited. Let's take a quick look at what we're going to cover in this tutorial series. First, we'll set up an iOS project with SwiftUI and RealityKit. We'll use Reality Composer to create an AR game scene with physics properties. Then we'll write the code to load and display the scene you composed in Reality Composer. After that, we'll use SwiftUI to build our on-screen game controls and translate them into ball movement. With the controls in place, we'll use the entity component system architecture to structure our game logic. And lastly, we'll implement our endgame logic and display an endgame message to the player. With that plan in place, let's dive in. The first step is to create a new Xcode project. So, let's open Xcode and click Create a New Project. We'll select iOS as the platform and start with the Augmented Reality app template. If you'd like a deeper overview of how this template works, be sure to check out my video named Your First RealityKit App, where I create the Augmented Reality app template from scratch and go deeper into how RealityKit works under the hood. In the next dialog, we'll configure the project options. We'll name the project Rollerball. Select your team in the Team drop-down. Set your organization ID. We're going to use SwiftUI for building the interface and Swift as the programming language, and RealityKit as the content technology we're going to use. Click Next to choose a location to generate the project to. Now that we have created our Xcode project, let's inspect the generated code. In this version of Xcode, this template starts you with an app delegate, where you create your content view and add it to the main window of the app. If we take a look at the content view file, this contains the main SwiftUI view, which will be displayed when the app starts. Before we look at the rest of the code in this file, let's build and run the app to see what the default app experience looks like. When the app starts, the first screen you see is the AR view. As you scan the room, a gray cube will be anchored to the first horizontal surface detected by RealityKit. Let's switch back to Xcode and take a look at how that works in the code. The first thing we want to look at is how our AR view works. An AR view is the view in our app that looks like the camera view, and it's the view that will manage all the virtual content we'll be overlaying on the real world. An AR view is a UI kit-based view, not a SwiftUI view. Since we chose SwiftUI as the framework we'll use to build our screen UI, we'll need a way to use UI kit-based views in our SwiftUI content view. Fortunately, the Augmented Reality app template generates this AR view container struct to help us bridge the UI kit-based AR view with the SwiftUI-based content view. By using the UI view representable protocol, we can easily include our AR view within our SwiftUI view hierarchy, while still having access to the powerful features of our AR view. Inside the required MakeUI function, we create and set up our AR view. This is also where we load the default scene in the Experience RC project that was generated for us as a part of the Augmented Reality app template. If we open the Experience file in Xcode, you'll see a preview of what the scene looks like, and you'll notice it starts with a simple cube primitive. You'll also notice you can't click on the cube or edit the scene in any way, since we can only preview the scene in Xcode. To edit the scene, you'll need to tap on the Open in Reality Composer button in the scene preview. Before we do that, let's finish taking a look at the MakeUI view function in our AR container view. On line 24, we call the loadBox function on the experience type to load a scene named box, which represents our scene with the cube in it. For a closer look at this function, feel free to check out my Your First RealityKit app video, where I go deeper into this auto-generated experience type and explain how its loadBox function works behind the scenes. When we load the box scene, we're loading a type of an entity called an anchor, which we then add to our scene graph. Remember from my Your First RealityKit app video, a A scene graph is a data structure commonly used in game engines to manage the hierarchy of 3D objects in our augmented reality experience, and the 3D objects in our scene graph are referred to as entities. There are many different types of entities, one of which is an anchor entity, such as our box anchor. An anchor entity is a type of entity that tells RealityKit what the relationship is between the virtual content and the real world. In this case, the virtual content is our box scene. When you add an anchor entity to your AR view's scene graph, nothing will be shown until the anchor type is detected in the real world. For example, when we create our rollerball scene content in Reality Composer, we'll use the horizontal surface anchor setting. This will cause our virtual bowling ball and pins to be displayed on and anchored to the first horizontal surface that RealityKit detects in the real world, like the floor or a table. We'll get to that in a minute, but before we do, the last thing we do in the Make UI view function, after we load our box scene anchor, is add our anchor to the AR view's scene graph. And that's all the code you need to show our virtual content on top of the real world. With that overview of the template code in mind, let's finish the last step in this first video and compose our rollerball scene in Reality Composer. We're going to use the existing Experience Reality Composer file that the template starts us with. Click on the Experience file and then click on the Open in Reality Composer button to launch Reality Composer. In this version of Xcode, the Reality Composer tool comes pre-installed with Xcode. Once Reality Composer loads, you should see the default cube in the middle of the scene. For an overview of Reality Composer, again, please watch my Your First RealityKit app video where I go deeper into this default scene and provide an overview of the Reality Composer interface. Looking at the anchor panel, you'll see the horizontal surface anchor is selected. We'll want to leave this unchanged so that our bowling ball and pins automatically appear on the first horizontal surface we detect. You might notice that a lot of AR apps that you try will allow the user to tap on the surface they want to place their AR content on. To do that, you would use a technique called raycasting, which is outside the scope of this tutorial, but I'll be covering this technique in future videos. We're going to keep it simple for this tutorial and simply display our game content on top of the first horizontal surface that RealityKit detects in the real world. Let's talk about the 3D objects we want in our scene. To build the rollerball game, our scene will need a bowling ball, which the player will control, and 4 pins that the ball must knock down to win the game. First, let's rename our scene. Click on the Scenes button at the top to see the list of scenes in your project, and let's rename our box scene to Rollerball. Next, click on the cube and hit backspace to delete it, so that we have a clean slate to work with. Next, let's add our bowling ball. Click the Add button at the top and type bowling in the search bar to find the bowling ball and pin assets. It's worth noting you can use any kind of custom 3D models in Reality Composer. Have I mentioned I have a video named Your First RealityKit app video where I demonstrate how to use a custom 3D model? For this tutorial, we'll stick to the 3D models that Reality Composer provides for us to use out of the box. Double-click on the bowling ball to add it to the center of our scene. Then select the ball, and let's name it Ball. The casing here will be important later on, so pay close attention to the capitalization used here. Next, let's add 4 bowling pins to the scene. To make it easier to add 4 pins, add the first one by searching for it and clicking on it to place it in the scene. And then you can select the pin in the scene and duplicate it 3 times using the Command+D keyboard shortcut. Before we reposition the pins, let's give them all a name. Group select all 4 pins by holding down Command and clicking on each pin. With all 4 pins selected, let's set their name to pin again, paying close attention to the casing here. With our 4 pins added, let's reposition them to surround the ball. Since we're placing our AR content on a horizontal surface, we'll want to keep all our models on the XZ plane. In case you're wondering what that means, let's pause for a moment and talk about RealityKit's coordinate system. RealityKit uses a right-handed coordinate system. The positive y-axis points up, the positive z-axis points towards the user, and the positive x-axis points to the right. Right-handed coordinate systems are commonly used in 3D modeling tools, whereas game engines often use left-handed coordinate systems. It's called a right-hand coordinate system because humans like to use their prehensile, multi-fingered appendages to remember how things work. Since we're using a horizontal surface anchor, the horizontal plane is the XZ plane. Back in Reality Composer, you can use the blue-colored Z and the red-colored X transform gizmos to drag the pins on the XZ plane. Go ahead and reposition the pins to surround the ball. For the sake of keeping this game easy at the start, I recommend placing the pins close to the ball. You can click and drag on the grid to change your camera perspective to get a better look at the layout of the objects in the scene. This looks good for now. To better demonstrate RealityKit's physically based rendering, let's change the style of the balls and pins to the material named Realistic. Select all the objects in our scene by pressing Command and the A key, and in the Look panel, let's select the Realistic material. The realistic material used here will create highly realistic reflections when they're placed in the real world. Next, let's configure the physics in our scene. Click on the ball and click the Participates checkbox to tell RealityKit that our bowling ball should participate in the physics of our app. Next, let's change the motion type from fixed to dynamic. The fixed setting means the object won't move as a result of any forces being applied to it. However, it will still participate in the physics of your application and allow other objects to collide with it. This is commonly referred to as a kinematic object in other 3D development tools. Fixed objects are useful for things like a constantly moving platform in a game that helps the player get past a gap in a level. We want the platform to participate in the physics so that the player can collide with it and stand on it, but we don't want to affect the movement of the platform when the player lands on it. The movement of the object will be under full control of manually changing or animating its transform. The dynamic setting means the object will move in response to forces being applied to it by other objects, such as collisions. Since we want our pins to fall over when the ball collides with them, we need to use the dynamic setting. Next, select Wood as the physics material type. Material types define some of the physical properties of the entity, like friction and elasticity. You can also create your own physics materials in code, but we'll use the materials that Reality Composer provides for us out of the box. These material types are settings you'll want to tweak until you find something that feels realistic for your object. Bowling balls aren't made out of wood, but I found that the wood material type works the best to simulate fairly realistic physics for a bowling ball in our game. The collision shape is used to detect when physical objects collide in the scene. Since we need to detect when the ball collided with a pin, we need to set a collision shape that works best for our ball. Typically, you want to use a collision shape that most closely matches the shape of the object. For the bowling ball, the sphere collision shape makes the most sense. Let's do the same for pins. Group select all 4 pins by holding down Command and clicking on each of the pins. With all the pins selected, click on the Participates checkbox. Change the motion type to Dynamic. We'll use Plastic as the material type and Capsule as the collision shape. That's it. Our Roll A Ball scene is composed. Save the project by pressing Command+S and switch back to Xcode. When you click on the experience file, you should now see your scene preview update to reflect our scene changes. If you try to build at this point, you'll get an error in our MakeUI view function saying Loadbox is not a member of Experience. This is because we changed the name of our scene to Roll a Ball, and the code for the experience type has been regenerated. Let's rename the Loadbox function to Load Roll a Ball and build again. The error should go away. With that fixed, let's run our app. When we pan our camera around the room, the floor is the first horizontal surface detected, triggering RealityKit to anchor our scene content to the floor. It works. That's it for this video. In the next video, we'll use SwiftUI to build our screen UI that players will use to move the ball, and we'll begin using RealityKit's ECS architecture to start translating our screen controls into forces that will move the ball. I hope you found this video helpful. If so, please be sure to like and subscribe. My existence depends on it. Until next time, take care of each other, and please stop hitting robots with hockey sticks. See you soon.